Now we're turning to short run production. So I've included here on this slide an example production function for us. So we have output, quantity of output is equal to K to the 1/2 power times L to the 1/2 power. And because we're looking in the short run, capital is going to be held constant, right? It's fixed. So we're going to say that capital is constant at 4 units, whatever that might be. And we're going to substitute that into our production function. So we'll get the quantity of output is equal to the 4 units of capital to the 1/2 power times the amount of labor used time to the 1/2 power. So the square root of 4 is 2. So simplifying, we're left with quantity of output is equal to 2 times the amount of labor used, all to the, or excuse me, to the 1/2 power. So it's 2 times L to the 1/2 power. Our production function here in the short run exhibits diminishing marginal product of labor, like we talked about in the last video. So if we go ahead and find our marginal product of labor, it's how does output change as labor changes. We're going to use that partial derivative. So we'll apply our power rule. So we'll have 1/2 times 2 times L to the 1/2 power minus 1. So that's times labor to the negative 1/2 power. Simplifying, we're going to get that marginal product of labor is equal to 1 times labor to the negative 1/2, which we can rewrite as 1 over L to the 1/2 power. So you can see very clearly as labor grows, as the amount used grows, marginal product overall is going to fall. So if we turn to our table here, we can see that, right? Capital is held fixed at 4 units, and we're going to increase labor by 1 unit in each row. So we'll go from 0 to 1. When we go from no labor to some labor, we jump from output of 0 to output of 2. So that means that our marginal product of labor is 2. When we jump from 1 worker to 2 workers, now our total output is 2.83. And so our output goes up because of that additional worker, but only by 0.83, right? Similarly, when we jump from 2 to 3 workers, our output increases again to 3.46, but this time it's only a jump of 0.63. So you can see how marginal product falls with the amount of workers used, and our output is increasing all the way but by less each time. Included in this table is also average product of labor. So again, that's just quantity divided by labor. So for our first row here, it's undefined, right? Because labor is 0, you can't divide by 0. That's similarly why marginal product is undefined, because L is in the denominator for marginal product. If we go to when we have 1 unit of labor, we have an output of 2. So 2 divided by 1 is 2. When we have 2 workers, we'll have 2.83. So we have 2.83 divided by 2 is equal to 1.42. So each worker is producing 1.42 units of output. When we have 3 workers, we divide 3.46 by 3, and each worker is producing 1.15 units of output, and so on. Okay. Here you can see the short run production function graphed when we have capital equal to 4 units constantly, and only labor is changing. As you can see on our horizontal axis, it's labor, and then output is the vertical axis. So as we go from 1 worker, from 0 workers to 1 worker, we have that big jump in output to 2 units. When we go from 1 worker to 2 workers, we are again increasing output, but by less. And you can see that through the slope of the curve, right? So from 0 to 1, the slope of that production function is quite steep. Compared to 1 to 2, it gets flatter. And as we keep adding workers, right, the slope of our curve becomes flatter and flatter. I might actually be clear. Let me draw those lines at the points of the additional workers so you can see that more clearly. Okay, so initially our slope of our production function is very steep. And then as we get more and more workers, it starts to flatten out. All right. And that is due to that diminishing marginal product. So you can see that here on this slide. As the number of workers used increases, right? Our slope of our production function falls, and that gives us that diminishing marginal product. Right. So here again, I've included on the slide for you the derivation of the marginal product for the production function we're looking at. I did that on the previous slide for you, so we're not going to spend too much time on it here. But again, you can see labor's in that denominator. And so as labor grows, the value of marginal product overall is going to fall. Okay, let's do a practice question. This is for average product of labor. So we have a Cobb-Douglas production function of quantity equal to K to the 1/4 power times L to the 1/2 power. We're looking at the short run, so capital is fixed, and it is equal to 81 units. All right, so let's go ahead and substitute that into our production function. So we'll have output equal to 81 to the 1/4 power times L to the 1/2 power. If you know your multiplication tables, right, the quarter root of 81 is 3. So we'll get quantity of output is equal to 3 times labor to the 1/2 power. And the question here asks us to find the average product of labor when labor is equal to 100 units. So let's go ahead and substitute for labor. So we're going to have quantity. Why did my pen stop working? Quantity equal to 3 times 100 to the 1/2 power. The square root of 100 is 10. So that's going to get us quantity equal to 3 times 10. So we have, in this case, output of 30 units when we have 81 units of capital and 100 units of labor. But that's not the question. The question is to find the average product of labor. So we want to divide output by the amount of labor used. So in this case, that's 30 units of output divided by 100 units of labor. Those zeros cancel out. 3 divided by 10 is equal to 0.3. And so our answer here is A, right? That is the average product of labor. Next, let's do another practice problem. So in the short run, we have the following table. It's showing us capital fixed at 6 units and labor increasing by 1. And we're showing the impact on output of that unit by unit increase in labor. So based on this table, oops, sorry about that. Based on this table, we're asked, what is the marginal product of the 10th laborer? So we have our 10th laborer here. And we want to know how much then does output jump when we move from the 9th worker to the 10th. So we're going to look at that jump in output. So it's 50 to 54, right? The difference between those, of course, is 4. So our answer here is B. That concludes short run production for us. And in the next video, we will turn to long run production.